Welcome back to Lightspeed Learning, where we explore the history and science of telescopes from their earliest days to the marvels of modern space observatories. In today's episode, we step into the 17th century to witness a fascinating rivalry of ideas: Newton's reflecting telescope versus Gregory's reflecting telescope. Two designs, born almost at the same time, each trying to solve the same problem: the flaws of the early refracting telescopes. The problem with refractors. Before Newton and Gregory, astronomers relied on refracting telescopes that used glass lenses, but these lenses had a major flaw: chromatic aberration, rainbow-colored halos around objects caused by the bending of light at different angles. To fix this, telescopes had to be extremely long, some stretching over 10 meters. Clearly, a new design was needed. Gregory's idea, 1663. In 1663, a young Scottish mathematician named James Gregory proposed a bold new design: a telescope that used mirrors instead of lenses. A concave primary mirror collected the light. A concave secondary mirror bounced the light back through a hole in the primary to the eyepiece. This setup produced an upright image, making it useful for both astronomy and terrestrial observations. But there was a catch. The design was too advanced for the mirror-making technology of the time. Gregory never managed to build one himself. It wasn't until 1673, when Robert Hooke constructed the first working Gregorian telescope, that Gregory's vision became reality. Newton's breakthrough, 1668. Just 5 years after Gregory's idea, Isaac Newton built the first practical reflecting telescope in 1668. His design used a parabolic concave mirror to gather light. A flat diagonal mirror at 45 degrees reflected the light to the side, where the eyepiece was mounted. The result? A much shorter telescope with no chromatic aberration. Newton's design wasn't perfect. The side view inverted the image and introduced some distortions, but it was simple and achievable with 17th century craftsmanship. Newton's design wasn't perfect. The side view inverted the image and introduced some distortions, but it was simple and achievable with 17th century craftsmanship. Newton versus Gregory side-by-side image orientation. Newton's design produced an inverted image, while Gregory's gave an upright one. Ease of construction. Newton's was simpler to build, while Gregory's needed precise concave mirrors. Practical use. Newton's was perfect for astronomy. Gregory's could be used for both astronomy and terrestrial viewing. Legacy. Newton's design became the foundation of modern reflecting telescopes, while Gregory's inspired future improvements, like the Cassegrain design still used in observatories today. So, who won the battle? In terms of practicality and immediate success, Newton's telescope took the crown.